So now we're finally ready to get into what it means to be a surjective function, an injective function, or a bijective function. So let's say we have a set A and a set B. So this is our set A, kind of oddly shaped, but doesn't really matter. And this is our set B. Okay, let me grab a new pen. Perfect. And B has these three. Now, say it maps on like this. So, in this scenario, A is the domain, and B is the codomain. Right. And to be a surjective function, we're going to do surjective first. In this scenario, if you are a surjective function, if you have a surjective function, each element in the codomain has a mapping, a corresponding element in the A domain, right? So, as you might notice, this element has two corresponding A values, but that doesn't matter. Each element in B needs to have at least one corresponding element in A. If B had an extra element right here, and it didn't map to any, or it isn't corresponding to any element in A, this would no longer be a surjective function. So that's what it means to be a surjective function. So there's some terminology. We can say that for this function f maps A onto B, right? So for surjective functions, we use the phrase onto to describe the function mapping one set to the other set. That's perfect. Okay, so we're going to go on to the next type of function called the injective function next. So now we're ready to move on to the injective function, or injections. So let's draw an example here, a new example for the new type of function characterization, A and B, and say I've got like 4 elements here, and let's say we have 5 here. Why not? Okay, so let's do our mapping from A to B. Sorry, that's for that if you didn't get that. Okay, perfect. So in injective functions, this is an example of an injective function. Injective functions exist in that each element in B has at most one corresponding A value, right? So you notice that this element here is alone, right? There is no corresponding A value, but that's fine, right? Because the condition is each element in B has to have at most one, but it can also have 0 corresponding A values. Now, if this point here corresponded to this point instead, this B element would correspond to 2 different A elements, and that's still a function, but it's no longer an injective function. So whenever you have this scenario, when it's an injective function, we call it a one-to-one mapping. So now we're ready to move on to the third characterization of functions called the bijection, or the bijective function. So now we're going to move on to the last characterization that we use for functions, and it's called the bijection. So any function that is a bijection is a bijective function. So what bijections are is that they put surjection functions and injective functions together into one definition. So how does that work? Well, let's do an example. That's set A, that's set B, got 3 points in each, and they map like this. Nice and easy. That goes to this one if that wasn't clear, and this is going to be called function f, right? And notice this is both a surjective function and an injective function. How so? Well, in surjective functions, remember each element in B needs to have a corresponding A element, right? That's true. Injective functions state that each element in B can have at most one element corresponding element in A. That's also true, right? So both conditions are satisfied for injective functions and surjective functions. So we put that together and we say that's called a bijective function. So we've defined it, and kind of like notice, right? Like it's a very clean one-to-one correspondence, right? Now remember, we call injective functions one-to-one mapping, but in bijective functions there aren't any extra lone elements. Like these two wouldn't be in a bijective function, right? So every element has a corresponding A element, but there isn't some weird overlapping going on. It's just a very clean, characterization. Now, these are very important in later chapters with countability and cardinality, and we'll explore that in later videos if I get to them.